1. So here the question is the equation mod of x minus 1 minus mod of x minus 2 plus mod of x minus 4 equal to p has exactly q real solutions. So the total number of solution is q for different values of p. The best way to solve such type of the question is with the help of graph. Of course, you can solve it by making the different cases also, that if the x is lying in the range 1 to 2, 2 to 4 or greater than 4 or less than 1. But that will be complicated here. So it's better if we try to solve it with the help of the graph. Let's see how. Here the equation is mod of x minus 1 minus mod of x minus 2 plus mod of x minus 4, which is equal to p. So what are the critical points? Here the critical point is nothing. The graph will change at what all those values. I can say at x equal to 1, from here x equal to 2 and x equal to 4. So we need to plot the graph of this equation here. So let's plot a graph here on the x-axis and the y-axis. Plot all the critical points. There are 3 critical points here. So I'll mark these critical points that is 1, 2 and 4. So x is equal to 1, then I can say 2 and then 3, then 4, 5 and so on. Let's say on y-axis I'll mark 1, 2, 3, 4 and 5 and so on. So these are the 3 critical points. So I'll first of all mark all these 3 critical points here first of all. Alright. So mark these 3 critical points, that is 1, 2, 4. So x equal to 1, x equal to 2 and x equal to 4. So we'll observe what are the values of p, or p is basically y here. What are the values of y at these critical points here? So at x equal to 1. So if you substitute x equal to 1, what is the value of p here? So I'll substitute x equal to 1. So I'm substituting x equal to 1, I'll get 0. 1 minus 2 is mod of 1 minus 2 is equal to plus 1 and mod of 1 minus 4 is equal to plus 3. So I'll get this is equal to nothing but 2. So at x equal to 1, p is equal to 2. So I'll mark the point at x equal to 1, p is equal to 2. Let's mark this point here. Okay. Similarly, at x equal to 2, what is the value of p? So at x equal to 2, mod of 2 minus 1 is 1, 2 minus 2 is 0 and 2 minus 4 minus 2 and its mod will be plus 2. So it will be equal to 3. So at x equal to 2, the value of y is equal to 3. So at x equal to 2, I can say y is equal to 3. I'll mark this point here. So once I get 2 points, you can join this. Okay. So I'll join these 2 points here like this. So the nature of the graph is between 1 and 2, it will be like this here. Alright. Now, next here, it is nothing but at x equal to 3. So I'll substitute x equal to 3. And we'll try to find out not x equal to 3 but x is equal to 4, the critical point. So at x equal to 4, we can see 4 minus 1 is 3, 4 minus 2, it will be comes out to be how much? That is 2. So 4 minus 1 is 3 minus 2 and 4 minus 4 is 0. So that is 1. So at x equal to 4, the value of y is equal to 1. So I'll say at x equal to 4, y is equal to 1. So mark this point here like this. So we can plot the graph between 2 and 4 like this. Okay. All right. Now, next, I need to take one point which is more than 4 and one point which is lesser than 1. So to understand the pattern of the graph, whether it is increasing line or decreasing line. So let's take x is equal to 5. So if you substitute x equal to 5, p will be equal to mod of 5 minus 1 is 4 minus mod of 5 minus 2 is 3 and mod of 5 minus 4 is 1. So 4 minus 3 is 1 plus 1, it is 2. So at x equal to 5, the value of y is equal to 2. So you can see it here that it is basically, it will be an increasing function. So I can plot the graph like this. Okay. Similarly, take one point x less than 1. So if I take the value of x which is less than 1, let's take x is equal to 0. And if I substitute x equal to 0, the point will be mod of 0 minus 1 is 1, 0 minus 2 is equal to 2 and 0 minus 4 is 4. So that will be equal to 3. So at x equal to 0, y is equal to 3. So at x equal to 0, y is equal to 3. So I can mark this point and then we can plot the graph. Alright. So like this. Now with the help of the graph, we can find out what are the possible values of y. So let me make one table here. So first of all, we need to identify the values of P and Q. So the values of P and Q is nothing but the number of solutions. So number of solutions here, it is represented by Q. Okay. Now, we know the critical points. The critical points are 1, 2 and 4. So the and 1, 2 and 4 here. So how the values will change, that we need to observe here. Now, what are the values of P? If you observe, the first thing we'll be doing one by one here. Okay. All the vertex play a major role. So if you look at here, is there any value, or what is the minimum value of this entire expression? Can you see the minimum value of this entire expression is nothing but that is equal to 1. This particular point, this is 1. Okay. So is there any value which is less than 1? No. So I can say when P is equal to P is less than 1, what is going to happen? Is there any solutions? No. Whenever P is less than 1, what are the values of Y? If I draw a line like this one, whenever the value of P is less than 1, you can see this line is not cutting the graph at all. So if P is less than 1, we can definitely say there is no solution because the minimum possible value in this graph is 1. So whenever P is less than 1, the number of solutions will be 0. Alright, the number of solutions will be 0. So next point is if P is equal to 1. If P is equal to 1, so plot the graph P equal to 1 like this. And you can see the graph is touching it at exactly 1 point. Okay, this is cutting at exactly 1 point. So I can say at P equal to 1, there is exactly 1 solution. So the number of solution, which is the value of Q, is 1. Next, similarly, if you draw a line, next one between 1 and 2. Now, this is 1 and this is value 2. Okay, this is 2. This point is 2. So if I plot any line between 1 and 2, for example, it will can see if I plot any line between 1 and 2, it is cutting the graph at how many points? 2 distinct points. You can see this is 1 point and this is second point. So whenever the value of P, it is lying in the range 1 to 2, we can say the number of solution is 2. And when P is equal to 2, let's see, P is equal to 2. So if P is equal to 2, you can see it is cutting the graph at exactly how many points? 3 different points here. Okay, this is the point 1, this is the second point, and this is the third point. So when P is equal to 2, we are getting 3 solutions. For 3 different values of X, we can get P equal to 2 here. Now, next vertex is at 3. So take between 2 to 3, how the graph will change between 2 to 3. So between 2 to 3, if you look at here, if I draw a line between 2 to 3, it is cutting the graph at how many points? There is 1 point, 2, 3 and 4. So between 2 to 3, the number of solutions, okay, if Y is between 2 to 3, where it is here Y is represented by P, then how many solutions this equation has got? It has got exactly 4 solutions. Next, if P is exactly equal to 3, so you can plot the graph Y equal to 3 like this. If it is exactly equal to 3, so you can say it is cutting it at 3 different points, isn't it? So I can say there are 3 points. That is point number 1, point number 2 and point number 3. So when P is equal to 3, it is cutting the graph at 3 distinct points. So I can say the total number of solution is 3. And the last part, if P is greater than 3, like if I take 4 or 5, something like this one. So it is cutting the graph at how many points? Exactly 2 points. You can see this is 1 point and this is the second point. So when P is greater than 3, the total number of solutions, it is going to be equal to 2. So this is the complete analysis of the graph. And once you analyze this particular graph, on the basis of this, a lot of questions can be framed here. Alright. So here the question is, I need to find out the number of solutions. Alright. I need to find out the number of solutions which we have found out here. Now the question is asking, what are the different, which of the following relationship between P and Q cannot be true? So let's see which of the following relationship between P and Q cannot be true. So let's start with the first of all, one by one. P equal to Q, is that possible? Yes, that is possible here. You can see P equal to Q here. If for example 1 and 1, if P is equal to 1, we are getting Q is also equal to 1. And even in the case like 3 and 3, they are also equal. So can P be equal to Q? Yes, that is possible. So the answer can't be option number B. P equal to Q minus 1. Is that possible? Yes, it is also possible. P is equal to Q minus 1. You can see it here. P is equal to 2 and Q is equal to 3 in this particular case here. So here P is equal to 2 and Q is equal to 3. So 2 is 3 minus 1. So the answer can't be E. And in rest all the three options, we need to find out the ratio of P by Q. Now, if I look at this particular solution here, this last one, when P is greater than 3 and Q is equal to 2. So can I say P by Q, it is always greater than 3 by 2 and 3 by 2 is equal to 1.5. So P by Q can be greater than 1.5. 1.5. So option number D, it is equal to 5 by 3, which is 1.66. Alright, so is that possible? Yes. The value of P by Q, it can be equal to 5 by 3 also. So this can't be my answer. Similarly, if you look at here, one more solution here, this one. When P is lying in the range 2 to 3. So when P is lying in the range 2 to 3, okay, and the value of Q, it is equal to 4. So what are the range of P by Q in this case? It will be 2 by 4 to 3 by 4. So 2 by 4 is 0.5 to 3 by 4 is 0.75. So the value of P by Q, it can be also from 0.5 to 0.75. Option number A is 3 by 5, which is equal to 0.6. So 0.6 is possible. So the answer can't be option number A. So we are left out with only one of the option choice, which is option C. So option C is never possible. So the correct answer is option C. So I hope that this question is clear. And like I told you before starting posting these questions, that all the questions will be conceptual. In one question, you can learn a lot of concepts. So if you want to get yourself updated with such type of the conceptual question, you can subscribe to our Telegram channel. Every day, I'll keep posting 3 to 4 conceptual questions till the CAT, so that your basic concepts and the fundas will be cleared. Thank you.